Hello, I'm Chris Bachelor,
I'm Ergui.
and for our E3 project, we created an AM radio.
So for this radio, we made it to be able to receive signals from local radio stations, and it includes the following parts: an antenna, an amplifier, a receiver, and a speaker. And we will go into those parts in the following slides. And all those parts are made by ourselves except for the speaker.
So the big picture of the whole project is there's three components, as you can see. So there's the radio receiver that breaks down the signal of the amplitude modulated radio signal so that we can hear it, and then the antenna, which extends for a long distance. It acts as the way for it receives and the actual signal itself for the radio receiver to break down, and the audio out of the radio receiver goes directly into the LM386 audio amplifier that we use, so that out of the speaker we can actually hear something of loud volume. So the radio receiver, how does it work? Well, AM radio signals, also known as amplitude modulated, they have a carrier signal and a modulating sine wave signal. So by the change of the amplitude of the actual signal, we can hear the actual sound that we want to hear. And so our circuit used a tank circuit, also known as an LC circuit. This is a schematic of our radios. And then the combination of an inductor and a capacitance and a variable capacitor allows us to break down the AM signal so that into something we can hear. And the transistors and the circuit also helped with the demodulating of the circuit of the signal. Now the outputs of our radio receiver goes directly into the audio amplifier circuit we created. This is a schematic for it. With just the three transistors, you could barely hear anything from the speakers because the amount of voltage output is so low. And so when we feed it into the amplifier, you can hear the sound of the radio. Oh, my bad. Here we go.
Okay, for the antenna, so the signal itself is just too weak for the radio to play it out. The antenna is the device used to amplify the strength of the signal that we receive. So with the circuit itself, we can only hear buzzing, and the antenna is just a loop and a long stretch of wire. And yeah. So this is part of our implementation, and on the left is the inductor, and on the right is the loop of the antenna. Challenges. So at the beginning we used the breadboard, but we later found out it doesn't work for the receiver because itself has a lot of capacitance. So we then solder the circuit, as you can see in the picture. Also for the inductor, at the beginning we used a tiny ceramic inductor, but this just doesn't work because it was too small for the signals. Our final inductor design was copper wire wrapped 36 times around Pringle cans. So as you can see, we made one. It's not perfect, but it's just pretty good for the signals. Okay. Also, in the test, we found out that the way we place the antenna matters a lot, and later on we found out that the way showing the picture is the best way to receive the signals. And yeah, just as you can see in the picture, we place the stretch of the wire perpendicular to the direction of the signals, and place the inductor through the loop of the antenna. And for future improvement, we know that at this moment our radio is imperfect and there is some static noises. And to improve this, we need to make a better amplifier circuit to decrease noises. And also, we can make a better antenna to receive signals from a further distance. And yeah.
So we wanted to give a thank you to Professor Briggs and Tong for helping us with the circuit. Also, we have the references here for the schematics that we use to create our radio receiver. And for the full demo of our receiver, please check out our other video.
Yeah, thank you.